Hello and welcome back to the Foodborne Parasitology series of videos. Today we're going to talk about the water-related parasites. We have two main groups in this video and we're going to talk about Protozoa and Nematodes. Let's begin. In the Protozoa we have the Coccidia, which are the Toxoplasma gondii, the Cryptosporidium, the Cyclospora, and the Cystoisospora. Then we have the Giardia, the Microspiritium, and then the Amoebas. So let's start with the Toxoplasma. We already viewed the Toxoplasma in the meat-related parasites because the transmission is also through meat. And just a little recap of what it does. It is an intracellular obligated parasite. It has both sexual and asexual phases. It consists in oocysts that contain sporozoites. Then they have the trophozoite form and the cysts that contain bradyzoites. It starts from the cat feces and the cycle repeats. Basically, the cysts are formed into the tissues of these animals, or maybe they can, in this case, contaminate the water, and then we ingest those cysts or via meat or via water and veggies as well, because if we wash those vegetables with the water that is infected, then the transmission can occur as well. So the transmission is oral, contaminated water, vertical, and transfusional, as we talked about in the last video. They cause fever, abortion in pregnant women, blindness and epilepsy, and in immunosuppressed people they can create cysts in the eyes and in the brain. The diagnosis is through visualization of the parasite, serology or PCR. There's no specific treatment to this, and well, the prophylaxis is gloves, hygiene, controlling raw meat and milk, especially for pregnant women, and the cat litter boxes, very important. Then we have the other Coccidia, intestinal Coccidia, the Cryptosporidium Spp. They have three stages: oocysts, cysts, and spores. They create spores. Remember that is important. Oocysts can resist a lot of chlorine, and they are very resistant. We have both asexual and sexual phases in here, and they attack the digestive and respiratory tract. They create the parasite vacuole. Now, this is very important because they are not intracellular obligated. They infect by creating this vacuole alongside the intestine, as we are going to see now with the biological cycle, the life cycle. Thick-walled oocysts, sporulated, important, exits the host. Contamination of water and food with oocysts, recreational water like swimming pools, and this is very important because they are infective as they get out of the host. They can infect. This is the infective stage as well. As you can see here, infective stage. And then thick-walled oocysts are ingested by the host. And the cattle are major hosts, the cows. So once inside, they start with the oocysts that release the sporozoite. The sporozoite will convert into trophozoite, and then we have this asexual cycle where they reproduce themselves and they create merozoite, and then the sexual cycle where the merozoite differentiates, and basically we get male and females, and then they create an undifferentiated gamete, and then the gamete differentiates and they create a zygote, and then the zygote can create the oocyst that can get out the host, can exit the host, or they can also create the auto-infection and reinfect the same host without living. The epidemiology is based on the water quality of the country. So the countries where the water quality is worse will have more problems of Cryptosporidium, and they are very common also in swimming pools, because children don't usually have their bottom well clean, and they can enter the swimming pool and infect the other people, contaminating the water because they are infective as they get out of the host. They produce diarrhea and nausea and fever, and in immunosuppressed people the infection is persistent. It occurs this thing, the autoinfection. Then the diagnosis is through serology and coprology, of course, feces analysis. And unfortunately, we don't have any treatment for this. And in immunosuppressed people, we have the antiretroviral therapy to maybe try to stop that autoinfection. The prophylaxis is water treatment and feces control, especially in children. Then we have the Cyclospora cayetanensis, that is very similar to the Cytoisospora belli. So we're going to view them at the same time, because the life cycle is also very similar. They are a zoonosis. That means that it's a disease that can affect also animals and as humans. It's bidirectional. In the case of the Cyclospora cayetanensis, they are 10 micrometers of the size is smaller than the Cytoisospora, which is 30. They have oocysts with 2 sporocysts and 2 sporozoids each sporocyst. In the Cytoisospora belli, we have 2 sporocysts and 4 sporozoids in each sporocyst. The life cycle starts with the excretion of unsporulated oocysts in the feces. Then we have the environmental contamination of water. Oocysts sporulate in the environment. This is very important. Sporulated oocysts enter the food chain via water, because they are water-related parasites. And ingestion of contaminated food and water will infect us. And inside, they will do the excistation, which means they are going to release the sporocysts that will release the sporozoids. The sporozoids will attack the cells because they are invasive. There's an invasion of the intestinal epithelium, and then once inside, they reproduce asexually, and they create the merozoid, and then the merozoid will invade another cell, and they will eventually go for the sexual reproduction, the differentiation, and the creation of another oocyst that can exit the host and repeat the cycle. The same thing happens here. As I said, the only difference is the number of sporozoids, but the rest is the exact same thing. The epidemiology is cosmopolitan. That means everywhere in the world, mainly in Haiti, and the same here. They produce diarrhea and malabsorption and lung infection, and in some cases even the Guillain-Barré syndrome. Here is the same thing. The Guillain-Barré syndrome is the precursor, the pre-stage of multiple sclerosis. And the diagnosis is coprology, and in the case of the Cytoisospora, we have also the eosinophilia and the PCR. For both of them, we have the sulfamethoxazole, and in case of the Cytospora, we have the medical treatment, the specific medical treatment for the Cytospora belli. These two are not infective at exit, whereas we talked that Cryptosporidium is infective at exit. And the prophylaxis includes also washing your hands and water control, and be careful with washing your veggies, control of the waters in general. Okay, so if we move on, we have Giardia Spp. This is a very frequent flagellated and clonal parasite. Clonal means that they're all the same, they're very, very similar. And they have two phases, the oocysts, which is the infection stage, and the trophozoites that attach to the intestines. They attack us and they stay there in our intestines. The life cycle is the following. Starts with trophozoites are also passed in feces, but they do not survive in the environment. So we have the cysts that comes from the host, and the trophozoites, but trophozoite will not survive. Then the cyst will contaminate the water, and the water will contaminate the food, the hands, and everything, and then we ingest those cysts again. And once inside, we have the cysts, and they will eventually reproduce through asexual reproduction, bipartition, and then at some point they will cyst, and the cyst will get out in the feces, and the cycle repeats. The epidemiology is, well, they are basically everywhere, and they are zoonotic. The pathogenesis, well, the majority of times is asymptomatic, but it can also give us diarrhea, nausea, fever, and malabsorption of lactose, and especially vitamin B12. The diagnosis is through water concentration and clarification, and then via immunofluorescence or PCR we can detect it in the water. The treatment is with antibiotics, and in particular nitroimidazoles. And the thing is that it's very, very common in schools, so we have to be careful with the hygiene we have in schools, and the water control and treatment of the water, because if we boil the water, for example, if we have a good hygiene, and the problems with Giardia will be lower. Moving on, we have the Microspiritium. If you remember, we talked about Microspiritium in the fishery associated parasites. And well, they are intracellular obligated parasites. They're very resistant. They have very resistant spores with two layers, the endospore and the exospore. And they have the extrusion apparatus that they use to inject the sporoplasm inside the cells. They use it to attack. They are everywhere, especially in tropical areas. They create diarrhea. And we can detect them via water concentration clarification, and then immunofluorescence or PCR. And these two methods are for actually detecting. This is for preparation of the water, and this is for actually detecting the presence of Microsporidia in the water, like before with Giardia. The treatment is albendazole and antifungi. And the prophylaxis, well, water treatment, boiling the water, and control of the water as well. And then we have amoebas. We are going to view apathogenic, pathogenic, and free-living amoebas. Starting with apathogenic amoebas, well, we have two types, the mouth or intestine types, and they do not invade tissues, no invasion. They do not create amoebiasis, and yeah, they are water quality indicators, and they have two forms, the cyst and the trophozoite. The life cycle is not really important as they are not pathogenic, but they exit the host in form of cysts and trophozoites, and then they mature and we ingest them again, and they exist in the intestines. So this is very simple cycle. Epidemiology worldwide, and especially in tropical areas, asymptomatic because they're not pathogenic, and yeah, they're indicators of water quality. So their presence means that the water is not very clean, and we have to improve our control of the water. Then we have the pathogenic amoeba, and in particular the Entamoeba histolica, and it has two forms: the trophozoite, which is the invasive form, and it has no mitochondria, no Golgi, no endoplasmic reticulum, and the cyst, which is the infective form, and is very, very resistant. So one to invade the tissues and one to infect and spread. The life cycle starts with major cysts, which are ingested, and well, there is the exustation in the small intestine. Then we have the trophozoite. The trophozoite then creates cysts, and then the cysts live in the feces. They get out very, very easy. They can also invade all the tissues, as you can see here, the liver, the lungs, and the brain. This is the common traveler's diarrhea through contaminated water. That's the epidemiology. That means it's almost worldwide, everywhere. The majority of the times it's asymptomatic, and if we are not very lucky, we will have the traveler's diarrhea, which includes also bleeding and in some cases ulcers of the intestines. The diagnosis is by biopsy, coprology, of course, serology using the ELISA type, and PCR. The treatment is metronidazole, the prophylaxis, water and feces control. If we control the feces and we do not mix them with the water, we will prevent this to happen, and of course hygiene, and avoid the oral fecal contact. Then we have free-living amoebas. General characteristics: they live everywhere, there are no obligated parasites, they have digestive vacuoles, and they have spikes to hold on to tissues. The acanthamoeba, well, in Greek, acantha means thorn, and amoeba. So it enters the body through the eye. It lives in contaminated waters and soil as well. And it produces encephalitis and other damage to immunosuppressed people. This is the life cycle in short. The cysts to trophozoite, then through mitosis they replicate. The amoeba, the cysts and trophozoites can enter humans in various ways, but the most common is through the eyes. Then we have the Bermuda Vermiformis. They are thermoresistant. They create epithelial lesions, encephalitis, and keratitis. So they can affect the digestive system, and then the brain, and also the eyes. They transport in themselves the pathogenic bacteria like Salmonella, Staphylococcus, and Enterobacter. So they are very, very dangerous, not only by themselves, but because they have other bacteria inside them. This is the cycle in short. The cysts and trophozoites pass in feces, and then mature cysts are ingested. Then we have the exustation, the trophozoite multiplication, as always, trophozoites, cysts, and then the cysts can leave the host and repeat the cycle. And then the Naegleria fowleri, they live in contaminated water at 28 degrees, so pretty hot we can say. They affect immunocompetent people too, and they have 3 stages: the cyst, the trophozoite, and the flagellated stage, and they cause the primary amoebic meningoencephalitis. They are so common in places like Australia and Mexico that these countries have created legislations to fight these parasites. The cycle is the same: cyst, the trophozoite, flagellated form, in this case the replication, asexual replication, and then water-related activities such as swimming, underwater diving, and other water sports can result in water going up the nose. And amoeba penetrate the nasal mucosa. Amoeba migrate to the brain via the olfactory nerves, causing primary amoebic meningoencephalitis in healthy individuals. So they are very, very problematic. That's why Australia and Mexico made legislations for this parasite. Then we have the Balamuthia mandrillaris. They are on soil and suspended dust. They produce the encephalitis and cutaneous lesions and keratitis as well. That is the eyes inflammation. They become cysts if there is no food, and they are diagnosed with PCR. Here again, the cyst, the trophozoite, reproduction through mitosis, and amoeba, cysts, and trophozoites can enter human in various ways: through nasal passages to their lower respiratory tract, through ulcerated or broken skin. So if you have a wound, they will enter, and then they cause the diseases. Moving on, we have the nematodes. These were the roundworms. We have Angiostrongylus cantonensis, Ascaris lumbricoides, Trichuris tricura, and Toxocara Canis or Cati, and Enterovirus Vermicularis. We're going to start with Angiostrongylus cantonensis. This is a parasite in rats' lungs. They affect the paratemic and accidental hosts, and Sam's case. Okay, Sam's case is a case from a boy called Sam in Australia, if I don't remember wrong, and he basically ate a snail because it was a bet with his friends of the rugby team, and he got this parasite, and he got paralyzed, and unfortunately he didn't make it. Well, let's see what's the life cycle of this parasite. So eggs hatch in the lungs, and the first stage larva is passed in rodent species. So we have the eggs in the rat's lungs, and then the larvae come out of them in the feces. First stage larvae shed from definitive hosts are ingested by gastropod intermediate hosts. So the larvae L1 get inside the snail, and then they grow to L3. And well, if the rats eat again the snails, they get infected too, and the cycle repeats. And at the same time, we can get infected as humans if we ingest the gastropod or the larvae in contaminated fruits through water washing. And then the larvae migrate to the brain, occasionally in eyes or lungs, and they can reproduce inside our cells. They are common in China, India, Australia, United States, Brazil. They cause the meningitis eosinophilic, and that includes fever, headaches, stiffness, and seizures, and then paralysis in Sam's case, for example. The diagnosis is through serology and eosinophilia, because the antibodies will be very high. The eosinophils in bloodstream will increase. The treatment is not very effective, and what we can do is give those people the corticosteroids and halcyon mintics to lower the inflammation, and this as a general treatment for helminths. The prophylaxis, well, rats control is the main one and the most effective, because snail control is very hard. And then hygiene, of course, hands, food, and water washing always, and water control as well, as we are talking about water-related parasites. Then we have Ascaris lumbricoides. This is the white worm, the typical intestine worm. This is actually the picture I put in the first video of this series when I explained the nematodes. That picture of the white worm, it was an Ascaris. The males are smaller than females, and the females have approximately 30 million stored eggs, and they produce 200,000 eggs a day. The life cycle is pretty interesting because we have the adults in the small intestine. They will create eggs, and the eggs are going to get out in the feces. We have unfertilized and the fertilized egg. Then the fertilized egg creates the L3 larva. The larvae are ingested by humans, and inside the intestine they migrate to the lungs through the circulation. They can enter the portal hepatic system, they go through the heart, and the heart pumps them to the lungs. Into the lungs, they penetrate the alveoli, and they can get inside the nasopharyngeus, and doing that, being up here, they can get out or maybe swallowed down again, and that's the reinfection, and this cycle will continue until they are big enough to create new eggs. The epidemiology, well, they are everywhere, and they are soil transmission. Pathogenesis, well, lungs bleeding, because they will penetrate and actually do damage to our lungs. They will obstruct our intestinal tract, and we will have a low nutrient absorption because of that. The diagnosis is coprology, because they create 200,000 eggs a day, and PCR, because they can be found in the nasopharyngeals and the blood as well. Then the treatment is albendazole and mebendazole, and the prophylaxis, well, hands washing, teach children, soil and water control, because if we wash our hands when we eat, we will lower these cases enormously. Then we have Curis tricura. They have, of course, male and female, because they are nematodes. Male is smaller than the female, as always, and the female has 5,000 eggs. They have two regions, one which is thin and long, and another which is thick and short, where are the organs. As you can see in here, we have the thick and short, and the thin and long. The cycle starts with the unembryonated eggs in feces. Then we have the two-cell stage, advanced cleavage, and the embryonated eggs are ingested. So basically, from unembryonated to embryonated, and then we ingest the embryonated eggs. Then the larvae hatch in the small intestine, and they become adults, and the cycle repeats. And this parasite is one of the top 3 global parasites, and they are very popular and famous in tropical areas. The pathogenesis, well, is asymptomatic, but it can also give us diarrhea and intestinal bleeding in case we are immunosuppressed. The diagnosis, well, we need to find the egg. So we will have the coprology and maybe visualization or endoscopy. There is no specific treatment, and the prophylaxis, well, feces control is the only thing we can do really. But we can also put in here the water control to not mix feces with water. Then we have the Toxocara Canis or Catty. This is for dog and cat. This is the typical worm of dogs and cats. If Ascaris lumbricoides was the typical worm for humans, this is a typical worm for dogs and cats. The female is 15 centimeters long and the male only 5. They are similar to Ascaris indeed, and they have cephalic wings in the head. We as humans, we are accidental hosts because of the ingestion of the L3 larvae. This is the life cycle. As always, we start with eggs in feces, and then the unembryonated egg becomes embryonated with the L3 larva, and then the ingestion of the eggs by the dog or the cat or another animal or humans. The L3 larva enters, and then the adults are created in the small intestine of definitive hosts. In case they are not definitive hosts, as we are, well, the larvae migrate in tissues, and once in tissues, for example, the dog can eat the duck or the rabbit, and they ingest the larvae that are in the tissues of these hosts. And we are infected as well by these animals if we eat them. So ingestion of eggs or foodborne transmission. And as we are not the definitive hosts, like in the case of the rabbit and the duck, the larvae migrate to the tissues because they hope to be eaten by the dog or the cat. We have to mention that there is also the vertical transmission of this parasite, and then the epidemiology is, well, common between children that play with cats and dogs. This parasite will give us liver pain, blindness, fever, inflammation in the lungs, and even systemic inflammation if we are immunosuppressed. The diagnosis is with ELISA, serology, and we can also have the liver biopsy to find the encrusted cysts. There's no specific treatment in humans, but there are treatment pills we can give to our animals so they can stop having those parasites. And the prophylaxis include, of course, those pills and the hygiene, cat and dog feces control. And then as last one for the water-related parasites, we have the Enterovirus Vermicularis. These are 12 millimeters wide, female, and they produce 15,000 eggs around the anus. Then they can have autoinfection because of something I will explain now. And this is the most infective parasite of them all because it's transmitted through the air as well. It causes anal itching. Have you ever heard of the anal itching problem, especially in children? Basically, it starts with the eggs on the perianal folds. So they do not really get off the host, they are just there. And they cause itching. And then children especially, they will touch that part with their hands, and then they will probably put the hands in their mouth and they will ingest the embryonated eggs, and the cycle repeats because then they can grow as larvae and adults in the lumen of the cecum. And then gravid females migrate to the perianal region, and at night they lay the eggs again into the perianal folds, and the cycle repeats. This is very, very common in children. But the epidemiology says that 500 million people are affected with this, and especially in urban zones, in rich countries mainly. And what it does is, well, anal itching mainly, and the diagnosis is the Gram tape in the anus. This is something we should put on our children at night, and in the morning we can check if they have eggs in the tape. The treatment is mebendazole, and the prophylaxis, well, hygiene and especially children control. Maybe just stop them, tell them to not put the hands in the mouth and those things. Okay, that's it for this video. These were the water-related parasites, and I hope you liked the video. Click the like button if you did, subscribe to the channel, comment down below if you have any doubts, and in the description I will leave this diagram so you can have it. It's yours. You can download it for free. Share this video to your friends and family to let them know that they are invaded with parasites. I'm just kidding. In the next video I'm going to explain to you the fruits and veggies related parasites, and that will be the last video of this series. I hope you are enjoying it, and see you on the next one.